morning children. Today let us start with sulfur. As you all know, sulfur is the second element in group 16. Sulfur shows different allotropic forms, but out of all the allotropic forms, two allotropic forms are very stable. They are the rhombic sulfur or alpha sulfur and monoclinic sulfur, that is beta sulfur. Is it clear, children? So we are going to study about the stable allotropic forms of sulfur, that is rhombic sulfur alpha form. Rhombic sulfur is otherwise termed as alpha form, and the second one is monoclinic sulfur, that is beta form. If you consider rhombic sulfur, it is obtained by dissolving rolled sulfur in carbon disulfide. First you have to dissolve rolled sulfur in carbon disulfide. You have to dissolve it in carbon disulfide and evaporate the solution. After evaporating, the yellow colored crystals which is left behind is termed as rhombic sulfur. Is it clear? It is obtained by evaporating the solution of rolled sulfur which is dissolved in carbon disulfide. It has generally yellow color. And this rhombic sulfur has a melting point of around 385 Kelvin, 385.3 we can say that. And this is completely soluble in carbon disulfide but insoluble in water, and partially it is soluble in benzene, ether, etc. Is it clear, children? Now second one, if you consider, the second allotropic form of sulfur is called monoclinic sulfur, or it is termed as beta form. Now if you dissolve rhombic sulfur in a china dish and you heat it. You heat it and allow it to cool. After cooling, a crust will be formed on the surface. You just pierce two holes on the surface of this crust and take out the liquid from the china dish. Now whatever left inside the china dish, that will be colorless crystals which is having needle shape, that is termed as monoclinic sulfur. Is it clear, children? First you have to just heat this rhombic sulfur in a china dish and allow it to cool. On cooling, a crust will be formed on the surface, and just pierce two holes, make two holes on the surface of this crust and take out the liquid part. Whatever that is, the needle shaped colorless crystals which is left in the china dish is termed as monoclinic sulfur. Children, if you consider, we can say that this rhombic sulfur will be stable till 369 Kelvin. Or we can say that above 369 Kelvin, it will be changed to monoclinic sulfur. Okay, so monoclinic sulfur will be stable above 369 Kelvin and rhombic sulfur will be stable below 369 Kelvin. Or at this particular temperature, you can see the presence of both alpha and beta form, that is both rhombic and monoclinic sulfur, and this particular temperature is termed as transition temperature. Is it clear, children? The temperature at which you can see the presence of both alpha and beta form, that is both rhombic and monoclinic sulfur, is termed as transition temperature. And if you consider sulfur exists, we can see that it has a crown structure. That is, when sulfur is in acid form, it will be existing as a crown structure, and sulfur also exists as a chair-shaped structure. Here you can see the presence of X6 particles, and in addition to this, sulfur you can see as S2 in the gaseous state. Children, if you know, this S2 shows the same unique property of oxygen, that is, even though it is having even number of electrons, it also shows paramagnetic nature, that is due to the arrangement of valence electron in the anti-bonding molecular orbital. The same we have studied in case of oxygen also. Is it clear? The gaseous form of sulfur, that is S2, even though it possesses even number of electrons, it shows paramagnetic nature due to the presence of valence electrons in anti-bonding molecular orbital. Is it clear, children? That is about the allotropic forms of sulfur. Now let us study about the compounds of sulfur. The first one you can consider sulfur dioxide. Compounds of sulfur, let us study about sulfur dioxide. If you consider the preparation of sulfur dioxide, that is SO2, method of preparation. First, if you heat just sulfur in excess of oxygen, you will get sulfur dioxide. S plus O2 will give you SO2. Or we can say that any sulfide source, that is, undergoes reaction with acid or acid treatment, you will be getting sulfur dioxide. Is it clear, children? The sulfide source on reaction with acid also produces sulfur dioxide. Or on a large scale we can produce it by the reaction of ferrous sulfide or oxidation of ferrous sulfide will give you sulfur dioxide. These are the different methods for the preparation of sulfur dioxide. The sulfur dioxide can be reduced under pressure and it can be collected in steel containers. You can collect and keep it in steel containers. Is it clear, children? Now, if you consider the properties of sulfur dioxide, we can say that it is a colorless gas with a pungent smell. Sulfur dioxide is a colorless gas with pungent smell. It is highly soluble in water. If you just consider sulfur dioxide, that is, it reacts with water or it dissolves in water and results in the formation of an acid, that is H2SO3, which is called sulfurous acid. Is it clear? It is a colorless gas with pungent smell, but it is highly soluble in water and results in the formation of sulfurous acid. That is, along with alkali or water, it resembles with the properties of carbon dioxide. Suppose if you consider sodium hydroxide, when reacts with the sulfur dioxide, you will be getting two series of salts. In the first step, you will get sodium sulfide, Na2SO3 plus water. When this Na2SO3 reacts with excess of sulfur dioxide and it produces NaHSO3, sodium bisulfite or sodium hydrogen sulfide will be the product. So here you can see that the same way carbon dioxide reacts with calcium hydroxide. Is it clear, children? The sulfur dioxide reacts with chlorine in presence of charcoal acts the catalyst and produces sulfuryl chloride, SO2Cl2. Or sulfur dioxide reacts with oxygen in presence of vanadium pentoxide as the catalyst and produces sulfur trioxide. These are all important properties of sulfur dioxide. Sulfur dioxide acts as a reducing agent. It will be reducing ferric to ferrous. That is Fe3++, SO2 plus water will give you Fe2++, SO4 2 plus H plus. Is it clear? So sulfur dioxide reduces ferric to ferrous. Or this reaction can be used as a test for identifying sulfur dioxide. That is, SO2 reacts with MnO4- and produces colorless Mn2++, SO4 2- plus H plus. So just see, children, when sulfur dioxide is react with purple color MnO4-, it will be converted to colorless Mn2+. So this can be used as a test for the identification of sulfur dioxide. Is it clear, children? That is about the chemical properties of sulfur dioxide. And if you just consider the structure of sulfur dioxide, we can say that it exists as a resonance hybrid. Sulfur dioxide exists as a resonance hybrid. That is, this will be the structure of sulfur dioxide. Okay, due to this resonance structure, both the bond lengths in sulfur dioxide, that is SO bonds, will be equal. Is it clear? Due to this property of resonance, both these bonds, SO bonds, will be equal in case of sulfur dioxide. Now, if you consider the uses of sulfur dioxide, we can say that sulfur dioxide is used in refining of petroleum as well as in sugar industry. It is used for the refining of petroleum and sugar, as well as it is used for bleaching in case of wool and silk. First one, we consider that it is used in refining of petroleum and sugar. It is used as a bleaching agent for wool and silk. Or we can say that it is used as a disinfectant, anti-chlor, as well as for sterilizing water. Liquid sulfur dioxide is a very good lab reagent. It is an organic solvent, and the sulfur dioxide is used for the preparation of sodium sulfide, calcium hydrogen sulfide, sodium hydrogen sulfide. Is it clear, children? That is about the properties and preparation of sulfur dioxide. The rest thing we will study in next class. Thank you, children.